and papers ready? Let's do some maths, everybody. So in tonight's lesson, we are going to finish off our geometry, a little bit of geometry that we've got left. And next week, when we go back to class, to term 3's lessons, we're going to be starting off with geometry. So it should be fresh in your minds next week when we start off. But in tonight's lesson, we're going to finish off on some geometry, and then we're going to continue with what we were doing last week, Wednesday in class. So let's have a look at our lessons tonight. Our lesson tonight says, is PS, so I'm going to go highlight them for you quickly. So, all right. Is PS, so here's PS, a line, a ray, or a line segment? Is PS a line, a ray, or a line segment? A line, a ray, or a line segment? Is there anyone who can give it a go? Is there anyone who can tell me what would the definition of let's start with a line segment. Who wants to give me the definition of a line segment? What does a line segment mean? Okay, anyone who wants to give me the definition of a line segment? All right, Jaden, talk to me. What's a line segment?
A line segment is a line that starts at a point and ends at a point.
Fantastic, Jaden. So a line segment starts at a point. I like that. And ends at a point. Thank you so much, Jaden. Can I do a little example here? Would it be something that looks like this? Something like that?
Yes.
Happy with that. Thank you so much, Jaden. Thank you for your help. All right. So Jaden is 100% correct. Oh, and our screen has just disconnected, everybody. So sorry. Let's get that up and going for you again. Okay. So a line segment starts at a point and ends at a point. Jaden is completely correct. All right, let's carry on going while we're waiting for the screen to reconnect. Who can tell me in the meantime, all right, what is a ray? What is a ray, guys? Mar, tell me, what is a ray?
Ma'am, a ray has a start but has no end.
Good. So a ray has a start. I like that. So a ray has a start. But continues to infinity, can we say? Can we say that, Amar? All right, I think Amar is happy with me saying that. Okay, so array has a start and it continues to infinity. So if we look at it, it has a start. And when we say it continues to infinity, that means that we're going to put an arrow on it. Now, if you're thinking of a ray, a really good way to remember that, and the way that I remember a ray, is if I'm looking at the sun, okay? If I'm looking at the sun, and if I think about the way that I used to draw the sun when I was little and I was at school, all right? I used to draw the sun, and there he is, and he's got a smiley face, all right? And then I used to have rays coming out of the sun, also known as sun rays, hey? So there were my rays. All right. And finally, that must mean then that the last thing we have here, which is a line, okay, a line must continue from infinity to negative infinity. So a line will look something like this, hey? It will have two arrows on either So let's go over it again. A line segment starts with a point and ends with a point. Array has a start, so it starts with a point and it continues to infinity. And finally, a line goes from negative infinity, so an arrow going to the left and an arrow going to the right. So if we're looking at PS, guys, if we're looking at PS, and Amar has their hand up already, so I'm guessing, Amar, you're ready to tell me the answer. Amar, what is PS?
PS is a line segment because it has a start and a end.
Thank you so much, Amar. So PS is known as a line segment. Fantastic, Amar. Thank you. Because it had a start and it had a finish. Well done. Well done. Okay. In our next question, it asks us to now draw. So it says, draw array and a line that will never meet. So draw array and a line that will never meet. So we've spoken about what array looks like. We've spoken about what a line looks like. So I want you guys to go draw one on your page. All right. Go draw array and a line that will never meet. Go try. Go try. It's okay to be wrong, but I want you to go try. Draw array and a line that will never meet. Give it a try. It can look different. Everyone's is going to look different. Don't stress. Draw array and a line that will never meet. All right, let's have a look. So I'm going to start by drawing my ray first. So I'm going to go start by drawing my ray first. So if I'm drawing a ray, I'm going to have a start point for a ray. Obviously, I'm going to use a ruler, guys. Okay, I'm going to use a ruler, please. All right, my ray is going to have an arrow on it. Okay, you can draw your arrow on that. If you really wanted to, you could close your arrow as well. Either way, all good. There is my ray. All right, I'm going to go highlight that in yellow for you. Okay, so I want to draw a ray and a line that will never meet. So there's my ray so far. Now I'm going to go draw my line. So if I go draw my line anywhere over here, what do I know about that line? What's going to happen? What's going to happen if I draw my line anywhere over there? What will happen, guys? What will happen if I draw my line anywhere over here? All right. Will they meet if I do that? All right. Will they meet? They definitely good. They're going to touch. They're going to touch. Fantastic. Fantastic. They'll touch. So you've got some options here. You've got some options here. I see that we had one very smart person in the chat who was saying, I'm just going to see who it was that said that. I think it was Shakina. Let's go back here quick. So yeah, Shakina, was you? Absolutely. I'm so happy about what you said there, Shakina. So Shakina said that if we made it a parallel line, which we're going to learn about next week in our class, okay? If we make it a parallel line, something that looks like this, where they've got equal spacing between them. All right, so if we did array and we did a parallel line, those two lines will now never meet. Right, so if we had to do a ray and a line next to each other and we had to make them parallel, then they would never meet. Right, so that's one option. That's one option we have. Okay. Another option that we have is we could go do our ray. So there's the start of our ray. There's its arm going out. There's the arrow showing that it carries on going into infinity. So yes, we do have to draw the line on a ray, or the arrow, sorry, on the ray. Okay. Another option is, what if we had to go and draw the line at the bottom? All right, if we had to go and put that line at the bottom, why is he safe there, guys? Why is he safe there? Okay, he's also safe there because what's happening over here is that this is stopping that ray from coming any further down. All right, it's stopping the ray from coming any further down, which means that that ray and that line are safe from ever meeting. Do we have some other options? Yeah, we have some other options. All right, we could go and draw our ray. Give ourselves some more space. We could go draw our ray like this. Again, you're going to use a ruler. All right, and we could go draw a line on the other side of it, so it's parallel going this way. All right, so that also gives us, okay, that also gives us lines that are parallel, but that are never going to touch. All right, so as long as you had something that looks kind of similar and that your lines are never going to touch, that's all good. All right, I'm going to make it a little bit smaller in case you guys want to take a screenshot of the whole page so you have it all together. Okay, so there it is all together so that you can get a screenshot of the whole page. All right, does the line have to be below the eraser? No, it doesn't. Okay, it doesn't. Remember, we did it on this side over here. So there it was there where the line was above the ray. So there I did it for you there where the line was above the ray. It doesn't always have to be below. All right, Tara Jane, I know it's confusing. Don't stress. Next week, when you get back to class, you're going to be doing a lot more geometry, and this is just a little taster for you so that you get used to it. And when we do it again next week in class, it's going to make so much more sense as well, because now you've had the beginning of it, okay? You've had the beginning of it, and then you're going to have it in class, and then you're going to have it again at Watobe next week as well. All right, guys. So I hope that was good. I hope that you learned a little bit about rays, about lines and line segments. I hope that made sense, okay? Next week, Monday, we're going to get right into this. We're going to get stuck into it. We're going to be doing a lot of practice, okay? And we are going to learn exactly how to do this really, really well. So well done, everybody. I'm really proud of you for giving it a try. What we're going to carry on to tonight is one of your favorites, okay? We're going to have a look at doing some more fractions. So when we did fractions last week, all right, we were looking at different kinds of fractions. Okay, remember we did some fraction practice last week in the end of our lesson. All right, I'm going to go back to that for you guys so that you can remember. Okay, so we looked at fractions last week. We were looking at reducing fractions and making them bigger. Okay, so that's what we looked at last week, all right? And when we finished our lesson last week, we were about to go and compare our fractions. Okay, so we were about to compare fractions and we were about to go and see which one was bigger and which one was smaller. All right, so remember this is a Beat the Basics class, so that's what we're looking at for the rest of our lesson tonight. We're having a look at filling in the missing sign. We're choosing from greater than, less than, and the equal to sign. Okay, so as a reminder to some of you, maybe you're new here, maybe you're not, all right, we have two different ways that we look at those signs. Either we use the old crocodile method, where we say to ourselves, if we're looking at the crocodile method, the crocodile's mouth is always open to the side that is bigger, Or we can use the dot method. And the dot method is the one that I'm going to practice with you a little bit later when we have a look at these. So we're comparing which one of these is bigger, 3/5 or 3/10. Well, it's really difficult to compare something if they're not the same. So 3/5 and 3/10 are really difficult to compare if they're not with the same denominator. All right, who's going to help me out here? How am I going to get the same denominator, guys? We practiced it last week. We practiced last week how we do this, okay? Tara Jane, talk to me, Tara Jane.
Hi, ma'am.
Hi.
I think you have to start with the 5, and I think you times it by 2 to make the denominator 10.
Good, well done, Tara Jane. So Tara Jane is absolutely right. We wanted to get to be over 10. So what do? We multiply the bottom. So I'm going to go and work it out on the side here. So I say to myself, I'm going to times that by 2. And Tara Jane, what's the rule that we kept on saying again and again and again last week with fractions?
What you do to the bottom, you do to the top.
Well done. Whatever you do to the bottom, you do to the top.
Yes.
Okay, so Tara Jane is absolutely right. When she finishes doing that, she gets 6/10. Well done, Tara Jane. Thank you so much. All right, so now, Amishle. Talk to me, Amishle. Which one is bigger, 6/10 or 3/10?
6/10 is bigger, ma'am.
6/10 is bigger. Well done, Amishle. So I'm going to go and I'm going to put 2 dots by 6/10 because that's the bigger number. 1 dot by 3/10 because that's the smaller number. And I'm going to go join up my dots. Another way of looking at that is 6/10 is the bigger number, so the crocodile mouth is always open to the bigger number. Okay. Right, I'm going to do one more with you, and then I'm going to let you guys go by yourself. So I've got 1/2 and 5/10. All right, 1/2 and 5/10. These are nice, easy ones to start off with. All right, so Mulalo, what am I going to do?
We're going to take 2 and 10, and then we find the common denominator, which is 10,
Well
and
done.
then 2 into 10, which is 5. Then you times the 1 by 5. Then you get 5/2.
So I'm left with 5
and
over
5/2.
5/2 or 5/10.
Oh, 5/10. Sorry.
Well
Sorry.
done. Good. I knew you knew what you were doing. Good. Now, Mulala, tell me. I've got 5/10. I've got 5/10. Which one's bigger?
None is bigger. They're both the same.
They're both the same, so I'm going to put an equal sign here. Well done. Thank you so much. Cool. All right, guys. I'm going to make this a little bit smaller so you can see more numbers on my screen. Okay. Go and try some of those out for me. And as soon as you've had an opportunity to try them out, I'm going to give you about 3 minutes to try them out. You don't all have to do number 3 and then number 5 and then number 6. You can try whichever one you want. And as soon as you are ready to try, then I will take hands. So I'm going to put everybody's hands down for now. Right, thank you so much, Mr. Hugo. Okay, I'm going to give you 3 minutes to go and try. So if you finish all of them in the 3 minutes, that's cool. But I would like you to all try first. You're going to get 3 minutes first. We're not going to take any hands yet. Okay. All right, go and give that a try. Yo, Amar, you are ready already. You are on fire today. Well done. All right, guys, you still have 2 minutes. Still have 2 minutes, everybody. Yo, Mzila, you also ready? Well done.
Well done,
Right.
everyone. Keep up the good work. You are doing excellent.
Okay, keep it going. 2 more minutes. See how many you can finish in 2 minutes. There's 5 there. See if you can do all 5. One more minute. Hey, 1 more minute, everybody. All right, I am ready for hands. Yo, that hand was quick, Grace. Right, Grace. Hello, which one are you doing with me?
Hello, ma'am. I
Hello.
would like to do 3.1.3.
Wonderful, Grace. Let's go. How did you do it?
Miss, I first wanted to see how to get the denominators to be the same. So I times the bottom by 10 and the top by 10.
Well done, you're a rock star. Good, cool. So when you did that, you were left with 70
I
over
was
100. Am I right?
Yes, Miss.
Well done. Cool. Right, which one's bigger?
70 over 100.
So I'm going to put 2 dots and 1 dot, and I'm going to join them up. Does yours look the same?
Yes. Yes,
Well
Miss,
done,
it does.
Grace. Well done. I'm really proud of you. Well done.
Mm.
All right, let's go Unati. Unati, which one are you doing with me? Unati?
Hello.
Hi, Unati.
Can I do? Hi. Can I do 3.1.6 with you guys?
Of course you can. Let's go.
Okay. So then, I first have to find out 5 times what makes 100. So I times that by 25.
25. Okay. 25.
And then I times the numerator by 25 as well.
Okay. And what's 5 times 25?
It's 100.
Are you sure, Nati? Let's go do the workings here on the side quick. 25 times 5. Let's double check. 5 times 5 gives me 25. So I put the 5 and I carry the 2. 5 times 2 is 10. Plus 2 gives me 12. Whoopsie.
Oh,
You make a small mistake. Small mistake. Small mistake. Let's fix it.
yes.
So do you agree it's going to be maybe 5 times 20?
Oh, yes.
Okay, cool. All right, so 5 times 20, I'm happy now that that's 100 on the bottom. And what's 2 times 20?
40.
Well done, that's 40. All right, which one's bigger?
They're both the same.
Well done, cool. You see, you made just a tiny mistake, but it wasn't easy to fix.
Yes.
Well done, thank you so much for the help. All right, let's go with Melo. Hi,
Hello, ma'am.
Melo.
How are
Which
you,
number are
ma'am?
we doing together? I'm good, how are you?
I'm good. Ma'am, we are doing 3.8 together, ma'am.
Okay, 3.1.8. Right,
Or
let's
8.
go, Melo.
So, ma'am, you
Oh.
have to say 5 times 20,
Good.
which equals 100, ma'am.
Well done.
And then you have to say 4 times 20, which
Good.
equals 80, ma'am.
Fantastic.
Yes, ma'am. So,
Now,
ma'am,
which one's bigger?
80 over 100, ma'am.
Good. So I'm going to do 2 dots here, 1 dot there, and I'm going to join them up. Does yours look the same?
Yes, ma'am.
Well done, Melo. Thank you so much for the help.
Pleasure.
I need the bathroom.
All right. And let's go with somebody else who we haven't heard from in a while. Let's go Kwezi. Kwezi, you're going to do the last one with me. Let's go. I know there's 2 more, but you do the last one. Which one do you want to do with me?
I'm not sure. I was
Number
planning
5
to
or number
onboard-
9? Kwezi, you still there?
No, I'm okay. I'm okay.
You're okay. You're not going to answer.
Yeah, I'm not sure.
Did they steal all your numbers? Okay, Kwezi, I'm going to ask somebody else then. Thanks, Kwezi. All right, let's go Katleho. Katleho.
I'm going to do 3.1.5.
Awesome. Let's go Katleho. What do I need to do?
You're going to say 10 multiplied by 100 is 1,000.
Rockstar.
And then you're going to say 9 multiplied by 100 is 900.
Amazing. Okay, which one's bigger?
900 over 1,000.
Good girl. Awesome. Join up my dots. Does yours look the same as mine? Katleho, you and me the same. We got the same numbers. Okay, sounds like Katleho, I might be losing her. All right, let's do the last one together. So I'm going to do the last one for you guys. So I'm going to see that I actually need to times this one by 10 and times the top by 10. Then I say to myself, okay, well, 750 is much bigger than 650. So I've got 2 dots on this side, 1 dot on this side, and I join them up. Well done, guys. You are rock stars. You are amazing. Okay, you are definitely beating the basics tonight. Okay, let's have a look at our next question. Our next question says, all right, write down from smallest to largest. So write down, okay, write down from smallest to largest. Write down from smallest to largest. So I'm going to go do 4.1 with you guys. So in order to write down from smallest to largest, I need to say to myself, well, to compare these fractions, I need them to be all the same. So at the moment, I've got a third, 1 over 3, 6 over 6, 2 over 3, and 1 over 2. That's not going to work for me. So I need to find the lowest common denominator. And if I'm looking at that, I've got 3, 6, 3, and 2. So what can all of those numbers go into? They can all go into 6. So if I'm looking at 1 over 3, how do I get the 3 to become a 6? I times it by 2. Whatever I do to the bottom, I do to the top. So this one is going to be 2 over 6. My next one I'm happy with, that's 6 over 6. My next one is 2 over 3. So whatever I do to the bottom, I do to the top. And finally, the last one is 1 over 2. So what do I need to do? I need to times it by 3 on the bottom. Whatever I do to the bottom, I do to the top. So I've got 3 over 6. Now my instruction said to me to write it down from smallest to largest. So from smallest to largest. Who can tell me in fancy words? What's the fancy way of saying that? Who knows? Who can tell me in the chat the fancy way? Oh, I've got hands already. All right, the fancy way of saying that. I think Shakina was first one off there. Shakina, what's the fancy way of saying smallest to largest? Shakina?
I think it's ascending order.
Well done, Shakina. Thank you so much. Okay, so Shakina is absolutely right. The fancy way of saying smallest to largest is to say ascending order. Well done. Okay, so if I'm writing this from smallest to largest in ascending order, all right, the smallest number I've got here out of 2, 6, 4, and 3 is definitely 2 out of 6. My next one will be 3 out of 6, then 4 out of 6, and then 6 out of 6. But it's important to remember that we need to put it back into its original numbers. So 2 out of 6 was the same thing as saying, so my final answer was 1 out of 3. Then I had 3 out of 6, which was the same thing as saying a half. Then I had 4 out of 6, which was the same thing as saying 2 out of 3. And finally, the last one that I had there was the one I had originally, which was 6 out of 6. So my final answer for this question will be 1 over 3, a half, 2 out of 3, and 6 out of 6. It's really important that you make sure you do the last step. All right, so I have 2 sums there for you guys. All right, I have 2 sums here for you guys, and make it a little bit smaller so you can see both of them. All right, number 2 and number 3. Hopefully you can see both of those on my screen. Number 2 and number 3. I am going to give you another, let's say, 4 minutes to try those ones because number 2 is quite long. So let's do 3 minutes on the clock. All right, you got 3 minutes on the clock. I want you guys to go try that for me. Go try that for me. 3 minutes on the clock. So at 17:41, we're going to start taking hands. Go and give it a try, guys.
Well done, everybody. You are doing excellent. And in the meantime, for all the fast students that are going to be done in 2 seconds, I want to ask in the chat, what's a different way of writing 6 over 6? Who can tell
nice
me
one,
that?
Mr.
6
Hugo.
over
Nice.
6. No hands. I need it in the chat. Teacher Kirsty said no hands yet. So there's no hands in the chat. All the fast ones.
What's the same thing as saying 6 out of 6, guys? Mr. Hugo is asking. There's all our fast students that were quick. Yeah, you have 2 minutes left. Nice, well done, guys. Yo, Katlejo, you were quick. Well done, guys. Well done.
Nominator and your denominator is the same. It makes for one whole. It's good
Well
to always
done.
remember that. I just refreshed your memory for those that might have forgotten. Well done.
Well done. Okay, you have 1 more minute left. One minute left, guys. Oh, number 2 and number 3 are such nice sums, guys. Sure. Two and number 3 are lovely sums, especially number 3. All right, so our 3 minutes are up. If you haven't finished yet, don't stress. We're going to go through it together. Let's have a look. Who is ready to do either number 2 or number 3 with me? Can I have some hands, please? All right, so I see Shakina, your hand was up first. Shakina, which number are you doing with me?
Ma'am, I can try and do number 3.
Perfect, Shakina. Let's go. Right, Shakina, step one, Shakina, what was your lowest common denominator?
I was a little confused about looking for the lowest common denominator. So I first tried to times the fractions to get the biggest number out of them all.
Okay, cool. That's perfectly fine. So Shakina's saying that sometimes it's really difficult to go and try find the lowest combination, especially on a test, Shakina. I agree with you. Sometimes in a test, to go and try find the lowest common denominator, and now you're stressed, and sometimes it's just easier to times them by each other, okay? But that does mean you're going to get a huge one. So what did you get?
So first I said since the biggest number is 12, I said 2 times 4 and 3 times 4. 3 times 4 will equal to 12, and then 2 times 4 will equal to 8. So that will be 8 over 12. And then for the next number, I said 4 times 3 equals 12. And then 3 times 3 equals 9. So that's 9 over 12. Then for the next fraction, I said 6 times 2 equals to 12. And then 5 times 2 is 10.
Yep. And then you got to 9.
And then, yeah, that's the tricky part.
And then you were like, oh my gosh, what is going on? Am I right?
Yeah.
Okay. So can I teach you an easy way to do it?
Yes, please.
Okay. So we're looking for multiples, hey? Do you agree? That's what you're looking for when you're doing this. So if I'm looking at first we can do multiples of 3, multiples of 4, multiples of 6, and multiples of 9, and multiples of 12. So that's one way to go and do it. Okay. I'm going to start with multiples of 12 quickly. So I've got 12, I've got 24, and I've got 36. I don't really want to go any bigger than 36. I could go bigger than 36. I could go 48. I could go 60. I could go 70. You know what I mean? I could go bigger and bigger and bigger. Do you agree?
Yes.
Okay.
Yeah.
So let's go 12, 24, 36. Let's go up to there. Let's go to the 9 now because that's the next one. So multiples of 9, 9, 18, 27, and then 36, hey?
Yes.
I'm finding a pattern so far. So I've already seen that I've got a lowest common multiple there and a common multiple there. Let's go do 6. So 6, 12, 18, 24, 30, and 36. Am I finding a pattern?
Yes.
Okay. What about 4? 4, 8, 12, 16, 20, 24, 28, 32. Oh my goodness. And then 36. So there is a pattern, hey? And what do I know about 3? Can 3 go into 36? Definitely. Am I right?
Yes.
So by the time I've got here, I already know that I've got 36. Do you agree? Okay, so that's one really easy way to do it. Another way to do it is you could go and you could say to yourself, well, what's the highest denominator that I've got here? The highest denominator that I've got is 12. What's the lowest denominator that I've got? The lowest denominator is 3. 12 times 3 gives you 36.
Yes.
It's cool, hey? Maths is amazing. It's so beautiful. I love maths.
Yes, ma'am. Thank you, ma'am.
You're welcome, Shakina. No problem. All right, guys. So I'm going to do this with you very quickly. Okay, so if I want to do 2 over 3, I need to times the bottom by 12. Whatever I do to the bottom, I do to the top. So I'm going to get 24 over 36. My next one, to get 36 for the 4, I times it by 9. Whatever I do to the bottom, I do to the top. So I get 27 over 36. My next one, to get 36, I must times by 6. Whatever I did to the bottom, I must do to the top. So I get 30 over 36. My next one, I've got 9. To get 9 to be 36, I must times it by 4. Whatever I do to the bottom, I do to the top, and that gives me 28 over 36. And finally, I've got 11 over 12, so I times it by 3. whatever I do to the bottom, I must do to the top. So that gives me 33 over 36. Now I'm doing it from smallest to biggest. All the bottoms are the same. I don't need to worry. I'm just looking for the smallest number now. So my smallest number is 24 over 36. My next one up will be 27 over 36. Then I'll have 28 over 36, 30 over 36, and finally 33 over 36. So if I put that into the correct order that we had it in originally, well then I should have 2 over 3, and then to get 27 was 3 over 4, and then it was 7 over 9, and then it was 5 over 6, and then it was 11 over 12. So my final answer will look like this. Okay,